In this second video, we're going to analyze the DNS resolvers in terms of the privacy they can provide. So if I try to go into a gambling.com site, I get the IP address, and everything that I have done to request that IP address is in clear text. And we're going to be showing you how that looks like in a minute. So the ISP and anything in between that can intercept this traffic can easily see what is it that you go. You can argue that you didn't gamble at all, but you can't deny the fact that you went to that particular site. After you go into the site, you're going to go into an HTTPS session, and whatever you gamble or whatever you do on that site will be encrypted. But the fact that you went to the site is a metadata that can identify where actually you went, and that's the aspect that we're going to be covering next. As we did in the previous video, we are selecting here in the NSS lookup the Quad9 server, and we request for the gambling.com, and we get the IP address resolving here. To prove the point, I'm here with my QRadar system that has been configured to collect flows, and there's a separate video I did a while back to show how you do that. And we are looking here on the last 5 minutes of the traffic. And if we actually do a quick filter for gambling, because remember that we went to gambling.com and we look at this record in here, we see that in clear text there's the evidence that I've been going into that particular site. So DNS is a very old protocol. When it was created, none of this notion of privacy, nobody figured out that the internet was going to be as popular as it is today. And to solve this problem, there have been two technologies that are the main subject of this video. The first one is DNS over TLS. And the analysis I'm going to be showing you in here is one that our friend Leopoldo Aguirre, best known as Polo, with his good knowledge of both QRadar and the protocols, did for us, and he's sharing what he found here. So the first of those methods is DNS over TLS, standard since 2016, supported by the three DNS resolvers that we have been seeing here: Google, CloudFlare, and Quad9. The way it works, you need to either install a server or something in the router that supports that protocol, or a client, which is what we did, and we actually did it for Windows, and we're going to be showing you the test that we do. You can go to dnsprivacy.org to get the details. We want to keep this video short, and the installer is stoby.msi, and there is a file, a configuration file, that I'm putting a link to it in the video description, to the box link that we provide some of the stuff that we do with the videos in here, where you can actually get the configuration file already set up to work. In this particular case, we did it with Quad9. What you will see here in QRadar is that now the same query that we do is going to go over port 853 instead of 53, and everything is going to be encrypted. There's nothing that you do not know what is it that I was actually trying to go. Let's actually show that. So here we started the stoby.exe, and now if we go to the command line, so now what we need to do is to point to localhost, which is going to force the resolution of every DNS request to the Stoby client that we just had. So if we go back here and we look for gambling.com, the same request went to the Stoby client, and let's actually look at that in QRadar. So notice that here in QRadar we see that that's the request we just did. I'm going to open it in a minute, but notice that the port is 853 rather than 53, which is what I was doing before. Notice also that it is web secure, so it is actually encrypted already. And notice that the amount of traffic for the same request is actually considerably bigger, because you have all the handshake being done for the creation of the TLS session itself. And if we click on it and we see the details, there's nothing you can see. Everything has been encrypted. If you wanted to run this at home, instead of selecting here the local host, what you will obviously do is go into your network configuration and put localhost as the DNS resolver. So what could be a drawback of this approach, even though it's standardized and it's supported by everybody, is that in some locations you may have this port 853 being blocked. I don't think it is the case, but it might be the one. The other technology that exists to address the privacy over DNS is DNS over HTTPS. Not a standard yet, but supported by CloudFlare and Google. Quad9 is working on it, but it doesn't have support for it yet. So this one is a DNS proxy that is implemented on this client DNS script, and the details, you can actually see them here. But the advantage of this approach over the other one is that it uses standard 443, which is the HTTPS port, which you know for sure it won't be actually blocked. Let's actually see a request done in another machine on this 204 machine that we are using this approach, and we'll see how it's also encrypting the actual traffic. So here we're in the other machine. That's the DNS script. We go here, click on resolvers, and we're going to select, it's already selected the CloudFlare, and we don't need to apply settings. We already did that. So we have that one running. So we open a command window. As we did before, we execute NSS lookup, as we've done in this series video. We specify server localhost, which is 127.0.0.1, and we request resolution for gambling.com. And we got the address resolved here. Let's see this in QRadar's Qflow. As before, we see that instead of going on port 53, it's now going on port 443. Everything is encrypted. Notice again that the amount of traffic because of the handshake is actually bigger. And when we click, notice here the address resolution here to the CloudFlare one. And if we try to see, there's nothing that will be seen, that can be seen. Everything has been encrypted and the privacy has been protected. So you can see two mechanisms that gives you privacy and prevents metadata generated that tracks where you had actually been going, and we see how both actually work. Polo discovered also something interesting that I want to share with you as well. And the finding has to do with the fact that some, and in this particular case, the Wi-Fi used by the hotel, in this particular case, can actually intercept and give you the perception that you are going, for example, to Quad9, and in reality you are not. So therefore you will lose the protection of the Quad9 filtering malicious site, which is another consideration, you know, that what has been the big advantage of Quad9 is that it will protect you from going against malware and still preserve your privacy. The only con is, you know, that possibility of, you know, of having port 853 being blocked. But let me show you how that interesting finding shows up on the perception that you are using Quad9, when in reality you are not. First, notice that I'm using here my phone as the network being used. I'm not using the hotel network. And I put, as before the NSS lookup, I specify Quad9, and I put littleblessingcotton.com, and when I hit enter here, I get blocked because it's a malicious site that we have seen before. All is good so far. Now I'm going to switch to the Wi-Fi, which is, and this can be, you know, any website that might be intercepting this. And I go back here and repeat the actual resolution, and notice that now I get resolution. So it was not blocked. So this thing appeared to be going to Quad9, but in reality it is not. So that request was made over clear text. Now we are going to use the Stoby, the client that we have for DNS over TLS, to make sure that that is encrypted, and we also see the benefits that it will go to Quad9. So we change the server to localhost, and we're going to be requesting the resolution to the littleblessing.com. And notice that now it's not only encrypted, so we got privacy, but also we know that no one messed it up with, and it actually reached the Quad9, and I got the extra protection. So that's an interesting finding. Thank you, Polo, for sharing this with us and sharing that that finding as well.